It is commonly known as the Red Planet and is the fourth planet from the Sun. Welcome to the Planets of the Solar System series, and today we'll be taking a look at Mars. Let's take a look at Mars's physical characteristics. The Red Planet, as it is commonly called, gets its colour from the soil. The reason the soil is red is because the surface is rich in iron minerals. These iron minerals in the soil oxidize with the atmosphere, creating iron oxide, or more commonly known as rust. While also having an iron-rich soil, Mars has no tectonic plates, causing pressure to build up in the crust. Because of this, the surface is prone to cracking and fracturing, leading to extensive mountain ranges and valleys. The planet is, in fact, home to the longest valley and highest volcano in the solar system. Olympus Mons is the highest peak in the solar system, measuring 22 kilometers high. If you put it next to Everest, you can see the true scale of this landmark. The volcano was formed due to the lower gravity on Mars and higher eruption rate, which allowed lava to pile up over and over continuously. The longest valley is called Valles Marineris, which is 3,000 kilometers long and 600 kilometers wide. For a comparison, this valley is over 360 times bigger than the Grand Canyon on Earth. The valley looks like a giant scar across the Martian surface, but it isn't the only one. The planet has been battered with asteroids and has extensive craters across its surface. The largest of which is the Hellas Planitia, which is 2,300 kilometers across, or almost the size of India. Mars is also one of the most similar planets in the solar system to Earth. It is 6,779 kilometers wide, which is about half of the Earth's diameter. Its gravity is quite weak, at 3.7 meters per second squared, while its mass is 6.39 times 10 to the 23 kilograms. While Earth is the densest of the planets, Mars is the least dense of the terrestrial planets. This is mainly due to the internal composition of the planet. Mars has a large iron and nickel-based core, however its mantle and cross are made of lighter materials. Because it lacks an outer core, the planet does not have a strong magnetic field to prevent the solar wind from reaching the planet. In fact, Mars has an extremely thin atmosphere because of the solar wind. As the wind passed over the planet, it stripped the atoms directly out of the atmosphere. This occurred continuously over millions of years until there was barely any atmosphere left. The pressure is now less than 1% that of Earth's. Its composition is very similar to Venus's, in that it is comprised of 95% carbon dioxide. A couple other trace gases such as nitrogen and argon are present, but the pressure is too little to retain heat. Mars also has seasons like the Earth because of its 25-degree tilt. While the average temperature on Mars is minus 62 degrees Celsius, it varies from minus 153 degrees Celsius at the poles to 20 degrees Celsius at the equator. Another similar feature between Earth and Mars is that they both have polar ice caps. However, on Mars, these ice caps are mainly made of dry ice when CO2 in the atmosphere sublimates into solid form. Just like on Earth, the polar ice caps shrink and grow by 25 to 30% in size as the seasons change from summer to winter. The weather on Mars is also especially harsh. Martian dust storms are common due to the low gravity of the planet. As fine particles from the soil are kicked up into the atmosphere, they are superheated and move to the colder parts of the planet, creating extremely strong winds of up to 200 kilometers per hour. These dust storms can last for months, blanketing the entire planet. As well as this, it even snows on Mars. At the poles, the carbon dioxide ice caps sublimate to form a gas in the summer. As the poles move away from the sun into eternal darkness, similar to what happens on Earth, the carbon dioxide reforms into solid dry ice and falls over the ice caps once more. Now let's look at the orbit and rotation of Mars. Mars orbits the Sun every 687 days and rotates on its axis every 24 hours and 39 minutes. The Martian orbit is quite elliptical, ranging by 20% in distance from the Sun. At perihelion, or its closest distance to the Sun, the planet is 207 million kilometers away, while at aphelion, or its furthest distance from the Sun, the planet is 249 million kilometers away. Because its days are very similar to the Earth's, we use a very similar time system. You may have heard of the word sol before. This is simply the length of time for Mars to achieve one solar day. It is the time length used for all missions to Mars, including the Martian rovers. As said before, Mars has a 25-degree tilt, which causes it to have seasons. However, these seasons would actually last for almost 5 Earth months because of its orbital speed. Let's check out the two moons of Mars, Phobos and Deimos. Phobos and Deimos both resemble asteroids more than moons. Both are quite small, Phobos being 11.2 kilometers across and Deimos spanning 6.2 kilometers. However, Phobos orbits much closer to the planet than Deimos. Phobos orbits only 6,000 kilometers above the Martian surface and completes its orbit every 8 hours. Due to the strong tidal forces and speed of its rotation, it is doomed to form a planetary ring or crash into the Martian surface. Deimos, on the other hand, orbits at 23,500 kilometers away and takes 30 hours to complete its orbit. Phobos' main feature is the large crater in its side, known as the Stickney crater. This crater is over 10 kilometers across, almost the entire width of the asteroid. It is a mixture of carbon-rich material and ice, possibly hinting that it was captured from the asteroid or Kuiper belt. It has a gravity that is only 1/1000th the strength of Earth's, meaning that if you weigh 70 kilograms on Earth, you would weigh 70 grams on Phobos. Deimos is the smaller moon of the two, which also orbits much further out. It has a gravity 1/3000th that of Earth's, meaning that if a person weighed 70 kilograms on Earth, they would only weigh 20 grams on Deimos. The asteroid, like Phobos, is made of carbon-based materials and is a lot smoother than Mars' other satellite. Although Phobos is doomed to crash into the Martian surface, Deimos is slowly drifting away from the planet. Finally, let's look at some interesting features of Mars. In total, there have been 6 rovers sent to the planet, though only 4 of which have been successful. Sojourner landed in 1997 and lasted 3 months, while the next was Spirit that managed to roam the Martian surface for 6 years before becoming stuck in sand. The most successful missions of all have been Opportunity and Curiosity, which respectively lasted 15 and 6 years on the surface. As of today, Curiosity is the only working rover still exploring Mars. The rovers have left such a legacy that they have become almost synonymous with Mars exploration. When we think of Mars, we think of the rovers that explore its surface, making countless discoveries and taking countless photographs. One of the best stories to come out of the Mars rovers is Opportunity, nicknamed Oppo. This rover was only expected to last 90 sols, or 90 Martian days, but instead was able to survive for over 15 years, 60 times longer than planned. During its voyage, it took hundreds of thousands of images of the Martian surface, and through rock analysis discovered that liquid water had once existed on the surface. It is through the work of rovers like Opportunity that we were able to discover that life may have existed underground on Mars. The prospect of life on Mars has been tossed up over several decades by scientists because of the similarities between Mars and Earth. The main difference between our two planets is the temperature and radiation levels. Mars is a lot colder than Earth, with an average temperature of minus 62 degrees Celsius. Not only that, but because of its weak magnetic field, the Martian surface is constantly blasted with high levels of radiation. These two factors would force any life that existed on the planet to move underground, where conditions are more favourable. An interesting discovery made by Opportunity and Curiosity rovers is that organic molecules exist in the soil of Mars. This gives us two solutions: that life existed billions of years ago, but has long gone extinct, or that life exists further below the surface where conditions are better for survival. Given the rover's capabilities, we can only collect surface samples rather than subsurface evidence. But if humans ever reach Mars, the search for life will be one of the top priorities for NASA and ESA. And finally, to round things up, this is what Earth looks like from Mars. It is rather detailed considering it was taken from over 55 million kilometers away. It once again shows the vastness of space that surrounds our humble planet and moon, and how small we truly are. As always, thank you guys for watching and I hope you enjoyed. We are halfway through the Planets of the Solar System series, and is on to the gas giants next. Remember to subscribe for more weekly astronomy content, and until next time, goodbye.